We're looking at derivatives of x being a function of y. So when x is a function of y, we can apply some different strategies to find the derivatives. The first thing we can say straight away is what's actually a very interesting result and, contentious in some ways, but we've got dy dx and we're going to treat this as a fraction. So we're going to say that the derivative dy dx is equal to 1 over dx dy. So if you take the reciprocal of dx dy, you'll get dy dx, assuming dx dy is not equal to 0. So I'll put links below to sort of explain why we can even treat dy dx like a fraction, because that's not necessarily obvious. But we can in this case, and sort of knowing just this fact here can allow us to solve problems of this form. So just to maybe explain this a little bit more, if it's not very familiar to you, it's just like saying 4 equals 1 over 1/4, which I think you would agree is the case. 1 divided by 1/4 is 4. So it's sort of our, sort of a similar analogy that we're drawing there. Okay, so if we look at something like differentiate x equals y cubed, let's try and solve this problem with the skills that we already have. So we could get y to be a function of x. So we'd get y equals the cube root of x, just taking the cube root of both sides. And then we would get y equals x to the 1/3. Okay, then we take the derivative. So we bring 1/3 down the front, leave the x there, reduce 1/3 by 1. So it's going to give us negative 2/3. And then if we write it back as a surd, we get 1 over 3 multiplied by the cube root of x squared. So that is what dy dx would be. Now, let's see if we can do it sort of taking advantage of this information that we've just spoken about. So if we have the same problem, differentiate x equals y cubed. Okay, the first thing we're actually going to say, though, is we're going to say, all right, dx dy equals, one sec. Yeah, so we take the derivative of both sides with respect to y. So we get dx dy on the left-hand side, and on the right-hand side, we differentiate this with respect to y. So we get 3, bring the 3 down, y, reduce 3 by 1. So we get 3y squared. And so now we've got dx dy, which is sort of this part of the equation, right? So we can say, therefore, that dy dx is 1 over dx dy. So 1 over dx dy would be 1 over 3y squared. So we can sort of approach this problem a little bit differently, but now our answer is in terms of y, which is no less good than if it was in terms of x. If we did want it in terms of x, we could now take this and substitute in the cube root of x. So let's show how that, I'm going to show how that works. So recall that y equals the cube root of x. So now wherever there's a y, I'm going to put cube root of x. And so we get 1 over 3 multiplied by the cube root of x squared. So if nothing else, this has been an example of why this rule holds true. If you're more interested in sort of fully understanding why you can treat dy dx as a fraction, I'll put some links below and go and do some exploring, see what you can find out. Let's finish with a problem. See if you can differentiate x equals e to the power of y, and let me know how you go. Good luck.